Okay, tomorrow we're going to have a little quiz on knowing how to do long division with polynomials and also synthetic. So take a second and answer this, and I'll get right back to you. Okay, here we go. You should have started with an x squared, and then you'd have x to the third and then plus 3x squared. And then I add them up and make 8x squared, right? No, what did I do wrong? Forgot to make them both the opposite. Okay, opposite, opposite. And now 5 and negative 3 makes 2x squared. And I can't keep going until I do what? Bring down. And notice I want this, see how this is a binomial out here? I want this to always be a binomial here. All right, so I'm going to bring that 7x down. And I say I need a 2x here to make 2x times x make 2x squared. And the 2x times the 3 makes 6x. Change, that leaves 1x left. And then I bring down the plus 3. And then I can just say plus 1. And 1 times x is x, 1 times 3 is 3. Change the signs. And I have nothing left. So there is my answer. Yes, it worked. It is a factor. Okay? Now, there's that. And the other alternative is synthetic. What do you think is going to be faster? Synthetic. Now, you do have to factor in that I already have the problem written for this, so I'm going to not start my counter until I've written this problem out to make it fair. All right. Now, you guys count silently and see how long it takes me to do this one. 1, negative 3, 2, negative 6, 1, negative 3, 0. Done. How long was that? 7, 8, 10 seconds maybe at the most? Okay, so that's much quicker. Okay. This is the only bad thing about this. Can't move it, seems like. Is that it doesn't tell me what the answer is. Normally the answer is written up here. It just tells me that it worked. But if you know how to interpret it, it does tell me the answer. Because this right here is the root, and that means the factor was x plus 3. And this down here, do you remember how to do this? This is a 1, 2x, and 1x squared. It's really easy to forget and think this is like the constant place, but it's not. This place over here is just the remainder. That's the constant. This is how many x's I have, and this is how many x squareds I have. Okay, so this is the x to the zeros, x to the ones, and x to the twos. All right. Moving on to this one. This one will take you a second, but it's good practice. It's a long division. Go for it. You may do this using just the easy way, which is what? Synthetic. It's fine with me if we just do synthetic on this. It'll be a lot faster. Okay, there I have it all set up. Drop the 1 as your first thing. You could think of that as adding 1 plus 0, because you always add down. And then multiply diagonal like this. 1 times negative 7 is negative 7. And then add down 2. Multiply diagonal, negative 14. Add down 1. Negative 7. 5. 5 to 7 is positive 35. It worked. So now, would you please write your answer as a product of two binomials? That's the way the book would say it, or the way your test would say it. Write your answer as a product of two binomials, or two linear factors. Actually, it may not be linear factors. Two factors. Right. Somebody noticed that I had a positive 35 here. Oops, that's actually supposed to be negative. That's why that ended up being 0. Okay, back to the factors you should have should be x plus 7. That's the same thing we had here, but you can tell that from this. And that's just a 5. This is how many x's I have, 1x. And then I have 2x squareds, and this last one is a 1x to the third. Do I have to have the 1 in front? No. Raise your hand if you had that one right. Good. Your class is one of my quicker classes, which is great. That means you get more time for homework. Okay, this one is a trinomial on the outside. Now, by the way, just in case you want to know, there is two words for the thing on the inside and the thing on the outside. One's the dividend and one's the divisor. And it's really easy to get them confused, so I made up a little saying that helps me remember it. The dividend is in the den. Can you picture which one the dividend is then? It's on the inside. Dividend is in the den, like a bear in the den, hibernating or something. Okay, so the divisor now is a trinomial. I like to use the big words with you every now and then so that when you see them on a test, you don't freak out. So divide this polynomial when the divisor is a trinomial. Just try it. It acts just like the other ones. Just like the other long divisions. You can't do synthetic on this, though. It won't work. Because this actually is a product of x plus 1 and x plus 1, which is actually two different things. So we can't just check one root. Okay, so that's how we start. Notice how there's 3 terms out here. And so we are only going to work on 3 terms over here in this part, even though it's a 4-term thing. You always want those to match when you're actually doing the problem. All right, now I got to remember to change all the signs, negative, 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 and this is going to be, these will cancel, and then I have 3x squared plus 6x. Now what? Do plus 3. 3 times the x squared. Wait a minute, something's not going to work. Oh, that's what you're talking about. Bring down the 3. There's also a 3 that goes up at the top. 3 times the x squared is 3x squared. 3 times the 2x, 6x, and 3 times the 1 makes 3. It worked out nice because when I change all the signs, they'll all cancel and I get 0. And this times this makes that. All right. So it still works even with the trinomial as the, is the dividend or is this the divisor? Divisor, all right. This is one last one. I showed you yesterday how sometimes you don't even need the placeholders when you're doing long division, but sometimes you do. This is one of those times you do. If you try to do this without placeholders, it gets so confusing. I did it myself and I totally couldn't unwind it. It was just too confusing. So I strongly recommend that as you try this one, again, don't even bother with synthetic because this isn't just one root out here, the test. So we have to use long. And I got to have a placeholder of x to the 1 here, 0x to the 1s. And I have to have a placeholder in between this and this because there's no x to the 5ths. And I also need one between these two, and I need one between those two. So I need 3 placeholders. See if you can fill in your placeholders and try this one. It's the hardest one of all. See if you can handle that. Okay, so this is how I'm going to start. Then x to the 4th on top. X to the 4th times the x to the 2nd is x to the 6th. X to the 4th times the 0 makes 0x to the 5ths. And then x to the 4th times negative 1 makes negative x to the 4th. I change all the signs on it. And then these will cancel, and negative x to the 4th and positive x to the 4th, that cancels too. Wait a minute, everything's gone. Because the placeholders, they helped a lot. And now what? Bring down stuff. How much should I bring down? How many terms? 3, because we want this to be 3 terms and this to be 3 terms. You may notice I didn't bring down the 0x to the 3rd because I didn't need to. And there's my final answer. I have more time than I thought. So my final answer is this times this will give me that. But I don't really need those placeholders in there, so I can just say x squared. This one can be x squared minus 1, and this one can be x to the 4th plus 3. I know it's bothering some of you that I can just skip over this one and just not do it. But if I put that in front, won't I always have to match the front term, right? So if I had a problem where I was trying to match a 0x to the 2nd, and I have something over here, and I'm trying to match this first term, won't I just put a 0 on top to match that? Because 0 times anything would make it cancel. So that's kind of like a useless step because I just have a +0 on the top. That's why I didn't need that.